Alright, this is the second introduction to trigonometry part 2 video. In this one we're going to take a look at how to use right angle trigonometry to find an angle. If you haven't had the chance to watch the first video, I highly recommend taking a look at it. We look at how trigonometry is simply an extension of similar triangles and use trigonometry to find the side of a right angle triangle. In that video we looked at the steps. The steps are very similar whether we're finding an angle or a side, so I'm just going to kind of build on the steps that we've done. So our first step to finding an angle is we need to identify that it's a trigonometry question. In this case we still need a right angle triangle, and again in this example we can see we have a right angle triangle. It's marked down here, and plus we have to have two side lengths. So here we're given a side over here of 13 and a side over here of 9, and the angle down here theta is what we're trying to find out. So our next step is we need to label the sides. So remember, when we're labeling for trigonometry we use opposite, adjacent, and hypotenuse. So I'm going to go with that. The hypotenuse is our longest side. I just kind of call it HYP. For the opposite, always go directly the side across from the angle. Because we're trying to find out this angle, then we want to take, then this side would be the opposite. So we'll write that in. And then the side that's left over is your adjacent. And that's going to be at the bottom here. And so we got for that. We'll move on to our next step. So our third step, you have to select the correct formula. Now, if you remember our formulas, we used the abbreviation SOHCAHTOA to help remember the formulas. And what that meant was the sine of our angle, which we called theta, equals the side ratio of the side opposite divided by the hypotenuse. So there's the S, O, and H. The cosine of an angle theta represented the ratio of the side adjacent divided by the hypotenuse. And again, there's a C, A, H. And the last part, the tangent of an angle represented the ratio of the side opposite divided by the ratio of, divided by the length of the adjacent side. It's a little sloppy there, but it should work all right. So we got SOHCAHTOA. So we have to select the correct formula, and to do that we're just going to look at, well, what pieces of information do we have? Well, in this case we've got the opposite side, which is 9, and we've got the hypotenuse, which is 13, so we're going to use our sine formula in this example. So I'm going to write out the sine formula. Sine of our angle equals opposite over hypotenuse. And then our next step, so we're going to write the formula as I just did, and we'll fill in the values. So in this case I'm just going to fill in my side lengths. My opposite side is 9, and then my hypotenuse is 13. So when we did trigonometry to find the side, you had to put in your angle, and then you go to your calculator, and it would tell you the sine, that particular ratio of a triangle that had that particular angle. Now we're going to do the opposite. So the last step here is we're going to use sine -1, cosine -1, or tangent -1 to find the angle. And if you bring up your calculator, you'll notice your sine, cosine, and tangent buttons, and right above them it'll say sine to the power of -1, cosine to the -1, tangent -1. It's actually called Arcsine, Arccosine, Arctan. I'm not really sure what that means, but it doesn't really matter. And the way that those buttons work is I put in my ratio, so my side length, 9/3, and it will tell me what angle has that particular ratio. So if we look at how to punch it in your calculator, in this time I'm going to put sine -1, and then I'm going to put in my ratio, 9 divided by 13. And let's go take a look at that. So I'll turn it on. Again, first make sure that you're in degrees. Every calculator is a little bit different, but you should look for a D or a DEG display at the top, and make sure you're in degrees. So I can just go second function, sine -1, and again with this calculator it's prompting me. I can just put in the ratio 9 divided by 13. Make sure you close the bracket. And 43.8 degrees. So that angle would be 43.8 degrees. Now it's really common that you're going to get a decimal for your degree. Usually they don't get a whole number. Some people prefer to put 9 divided by 13 and to do that part first. So 9 divided by 13, so that's 0.6923 say. So 0.6923, and then you could do the sine -1 of 0.6923. And again, we're really doing the same thing here, but I'm just kind of doing it in 2 steps. And the only thing I recommend, if you do that, keep at least 4 decimals when you put in your ratio, because they're really quite sensitive, especially for the higher angles. So even if you made a small difference in here, like if we rounded this to 0.7, our angle could be off by a degree or more, which is more error than you'd really want. And again, we do it this way, 43.8 again. So that's it. Let's take a look at one more example, since I got you here. Whoops, let's go back. All right. So this one, again, looks a little bit different. We still have a right angle triangle. We still have 2 sides of the right angle triangle. We're trying to find the angle theta down here. And we can look at our step 1. We need a right triangle. Got that. Plus 2 sides. We got that. We're going to label our sides. Again, we look at this angle here. Now our hypotenuse is always the longest side. A little bit tricky here to see which one's the longest. But it's also, if you go opposite your right angle, you always have your hypotenuse. Here's our hypotenuse. Opposite to our angle is going to be directly across over here. And our third side is the adjacent. And next we're going to select the correct formula. So I'm just going to write the SOHCAHTOA down here because that's a little bit faster than writing out all the formulas. And we look at, well, what sides do we have? I've got the opposite. I've got the adjacent. So we're looking at the TOA part. And we write down our formula and fill in the values. So our tangent of theta equals opposite over adjacent. We'll fill in our values. Again, theta represents the angle, which is what I'm trying to find out. I don't know that, but I do know my sides. 87 divided by 110. And then our last step, using our calculator, put in this case, tangent -1. So if tan -1 of 87, that's a little sloppy, I'll do it again, of 87 divided by 110. And again, when we do that, we're basically saying, well, what angle in a right triangle will have a ratio of the opposite and the adjacent? That's 87 over 110. Sounds a little bit bizarre, but that's all we're doing. So tan -1, put in my ratio, close my bracket, and that angle is 38.3 degrees. And there you go. That's it. Thanks for watching. Bye-bye.
You're still here? It's over. Go home. Go.